Okay, so Junior Roberts here again. We're on part 4 of our logic gate series. I've done parts 1, 2 and 3 in earlier videos. I will put a link in the description and at the top of this video so you can go ahead and check out those videos. So we're going into part 4 right now, and in part 4 our focus will be on the NAND gate. So let's go right into it. Okay, so some learning objectives for this video. The first thing that we're going to be looking at is to define the NAND gate, derive the truth table for the NAND gate, and formulate a Boolean expression for the NAND gate. So as usual, we're going to start out by figuring out what is the NAND gate. Okay, so the NAND gate is a type of logic gate that accepts two logical values as input and produces a single logical value as output. And here again we have the symbol for the NAND gate. So as we realize, it looks similar to the AND gate. The only difference with the NAND gate is that there is a bubble at the front here, and typically whenever we see a bubble on a logic gate like this here, this bubble means an inversion, right? So whatever value is taken in will be inverted once it reaches to the output here. So we'll actually discuss that when we talk more about the truth table and the operation of a NAND gate. Okay, so the function of the NAND gate is similar to that of an AND gate with an inverter connected at its output, right? So that is why when we look at the symbol for the NAND gate, we saw where it looks similar to the AND gate. The only difference was the bubble at the end, and that bubble serves to invert whatever value was present at the output. So essentially what this means is that the NAND gate can be represented by an AND gate connected to a NOT gate, right? So when we look at the function, we will see the truth table, and the truth table will give us more details in terms of how the NAND gate operates, right? But as I said before, the NAND gate could be represented by an AND gate with a NOT gate connected to the output. Okay, so we know that each logic gate has its own truth table and Boolean expression, and first we're going to take a look at the truth table for the NAND gate. Okay, so again, we know a truth table to be a table which shows the possible inputs and output for a logic gate, right? So here we have the truth table for the NAND gate, and if we recall how to fill out the truth table, we're going to start with this column B for input B, and again we know we have input A and input B since this NAND gate takes in two inputs and produces a single output. So we're going to start with this column first, and we're going to start with 0, alternate all the way down, and then here we're going to start with 0, remain 0, and then we're going to alternate, and then we're going to remain. So let me just go ahead and fill out the table. So we start with 0 in the first row, then we alternate to a 1, alternate to a 0, and then we finally alternate back to a 1. Then in column A, we're going to start with 0, right? We're going to keep our 0, then we're going to alternate, right? And then we're going to keep our 1, right? So those are the possible inputs that we can have for the NAND gate, right? And again, as I said before, the NAND gate operates as if it was an AND gate with a NOT gate at the end. So we know from before that whenever we have 0 and a 0 going into an AND gate, we would get a 0. But because of the presence of the NOT gate at the end of the AND gate to make the NOT gate, when we have a 0 and 0 going to the AND gate, we will get a 0, and then at the end that value will be flipped, so we'll get or inverted, so we will get a 1. Similarly, when we had 0 and 1, we will get a 0, but because of the presence of the NOT gate at the end of the AND gate, in the case of the NAND gate, we will get a 1. Similarly, 1 and 0 would typically give us a 0 for the AND gate, but because of the inverter at the end, we will get a 1. Now, typically when we had 1 and 1 in the AND gate, we would get a 1. But because of the NOT gate, we will get a 0. Right? So we see exactly how the NAND gate basically reverses the operation of the AND gate. Because we know for these 3 rows, we would have gotten a 0 when we had an AND gate. But because again this is a NAND gate and it operates in reverse to the AND gate, we would get a 1, a 1, and a 1, and a 0 right here. So this is the truth table for the NAND gate. Again, once we can completely appreciate the operation of the logic gate, we can easily derive its truth table. Okay, so we're going to now take a look at the Boolean expression for the NAND gate. Alright, so the NAND gate Boolean expression is given as the output X is equal to A and B, and then we're going to NOT that value. Right, so we have A and B, and then this indicates that we're going to NOT everything inside the bracket. And we know from algebra, we would typically evaluate the bracket first, and then we take whatever operation is on the outside. In some books, it might be represented as a horizontal bar atop here, but it typically means the same thing. Alright, so we have A and B, and then we NOT A and B to get our output X. So that's the Boolean expression for the NAND gate. Okay, so let's just quickly wrap everything together. So what we've learned so far is that the NAND gate is a type of logic gate that accepts 2 logical input and produces a single logical output. The NAND gate operation is similar to that of the AND gate with an inverter connected to its output. So in terms of the operation of the NAND gate, it would operate as if it was an AND gate with a NOT gate connected at its output. Okay, and we know that the Boolean expression which governs the NAND gate is given as X, which is our output, is equal to A and B, and we're gonna NOT A and B. Okay, so again, this was Junior Roberts with realjuniorroberts.com. If you enjoyed this video, please hit the like button and consider subscribing. If you think others would benefit from a video like this, please hit the share button so they can get access to this and other videos. Thank you for watching.